Welcome to my YouTube channel, that is SK Classes for Physics. So this is my first topics in Hargar Pathshala for you, class 10 plus 2. What is our topic? That is dual nature of matter and radiation. Dual means double. Dual nature of matter and radiation. तो थोड़ा सा आप लोग इसके बारे में पढ़ चुके, जैसे आपने ऑप्टिक्स स्टडी किया, तो you have seen the few phenomena that is explained by the wave nature of light and the few phenomena that is explained by the particle nature of light. तो जो wave nature of light है means light will behave like a wave and particle nature of light means कि the light will behave like a particle, radiation will behave like a particles. As you know, different scientists have different contradiction regarding this dual nature of matter and radiations. First of all, Newton's will come. He says the light have the particle natures. Light consists of corpuscles. Corpuscles means that is in blood. So particle nature of light is there. That is explained by which one? Our Newton. Then our Heisenberg comes. He gives the wave theory. Heisenberg theory. As you know, there is a concept of wavefront. Heisenberg theory. He explained that there is light is a longitudinal wave. Longitudinal wave means which requires some material for its propagation. Material medium for its propagation. So light is a longitudinal wave, just like a sound wave. Then it requires some medium. Then he says, whatever our space, it is pervading ether. इसके अंदर क्या है? Ether is the medium. लेकिन बाद में पता चला कि वहां पे कोई ether उथर नहीं है, क्योंकि मीडियम ऐसा होना चाहिए लॉन्गिट्यूडनल वेव के लिए जिसकी इलास्टिसिटी ज्यादा हो और हैव सम मास. लेकिन ईथर के पास तो इस तरह की कोई कंसेप्ट नहीं था. तो बाद में पता चला कि लाइट जो है लॉन्गिट्यूडनल वेव नहीं है. The different scientists का Hertz give the production of EM waves, the concept of EM waves. Then we will get the light is have the wave nature. It is a transverse wave. It is a transverse wave means it do not require any material medium for its propagation. As you know, EM waves means electric and magnetic field both are perpendicular to each other and they are propagating perpendicular to their direction of propagation, perpendicular to both electric field and magnetic field. That is our electromagnetic wave. Now, light is a transverse wave that will be followed, but what will happen? The day will come that we will do the photoelectric effect and the Compton effect. Now we are going to explain this photoelectric effect. What is photoelectric effect? That we will explain here. This phenomenon is only explained by particle nature, and the Compton effect is also explained by the particle nature of light, and the wave nature will fails there. Then what will happen? The scientist that de Broglie came, he says the light have the dual nature. Few phenomena will be discussed by particle nature and few phenomena will be discussed by wave nature. Ultimately, as the nature loves symmetry, there is a he and she in the nature. Nature loves symmetry. Then if light that matter, the light have the which one wave nature means matter has, then there is a wave that is associated with the matter. The electrons is associated with the wave, or that wave is called matter wave. So ultimately now we have the solution. Light have the dual nature. Light का कैसा nature है? Dual nature. Light have the dual nature means it will behave like a radiation as well as a wave. So we can say it as a barricles. Barricles we can say. Barricles means wave as well as particle nature. Barricles word use किया गया इसके लिए. क्या use किया गया? Barricles means it has particle nature as well as wave natures. So we will discuss now photoelectric effect. Before going to photoelectric effect, but we have to understand what is wave basically. So whatever the wave, you know, if there is a transverse wave is there, then there is a crust and troughs in the waves. Just like this, the wave is propagating. This is called crust and this is called trough, as you know. What will happen? Few terms that is associated with that wave. What is that? This is called amplitude of the wave. Maximum displacement from the mean position. ये mean position is the maximum displacement, उसको हम amplitude बोलते हैं. क्या बोलते हैं इसको? Amplitude बोलते हैं. You have to remember this. Suppose you want to swing. You want to enjoy yourself in a swing, but you want more and more amplitude you have to give it. See, this is swing. What will happen? You want कि हमें जितना ज़्यादा हमें क्या दिया जाए, amplitude दिया जाए, जितना ज़्यादा हमें क्या किया जाए, दूर तक झूला दिया जाए, उतना आप enjoy करेंगे. तो what this called? This is called amplitude. What is called? Amplitude. Amplitude. See, there is a term that is intensity of light. Intensity word means how much is the intensity is the light that depend upon intensity. Intensity is directly proportional to amplitude square. More is the amplitude, more is the intensity of light. Okay, you have to remember this thing. Intensity is directly proportional to amplitude square. More is the amplitude, more is the intensity of light. The second factor is there, that is the frequency. What is the frequency? You know, the number of of oscillation, number of vibration, number of revolution, number of rotation completed in 1 second is called frequency. एक सेकंड में कोई चीज कितनी बार, what is the oscillation means? See, suppose this is the pendulum, it will go from here to here, come to here, go to here. See, we can say it will go from here to here, come to here, then the one oscillation is said to be completed. How much time it takes to complete one oscillation? That is called time period. What that called? Time period. एक ऑसिलेशन को कंप्लीट करने के लिए जो टाइम लगेगा उसी के कहते हैं टाइम पीरियड. सपोज आवर फिजिक्स पीरियड इज एट 11 am. Not well, how much time, after how much time it will repeats? It will repeats after 24 hours. But the time period of physics period then at 24. But the time period of rotation of earth at 24 hours. But the time period of revolution of earth, that is 1 year. So what we can say, if this is the time period, what is time period? That is going to be T. T is the time period, that is time taken to complete one vibration. Either you can say oscillation, you can say rotation, you can say revolution, anything you can say, that is called time taken to complete one vibration, oscillation, rotation, revolution, that is called time period. What is that called? Time period. What is time period? Time taken to complete one vibration, one oscillation. तो इस एक चक्कर लगाने के लिए कितना समय लगता है? मतलब हम यहाँ से चलते हैं, हमने यहाँ से यहाँ वापस आने के लिए कितना समय लगा? That is called time period. That is called time period. See, what is one oscillation? See, we will go from here, go to here and comes to here. These are called extreme positions. This is called mean position. We will go from here to here, come to here. See, this is the amplitude. Amplitude is large in this case. See, if the amplitude is small, then we can say it is a vibration. This is called a vibration. Now, but what I want to say, there is another term that related with this wave, that is the frequency. What they are called? Frequency, that is denoted with nu. What is that denoted with the nu? Nu is called the frequency. What is nu called? Frequency. Frequency. Nu. See, what is the frequency? The number of oscillation, the number of vibration, number of rotation, the number of revolution completed in 1 second is called frequency. एक सेकंड में कितने बार ये ऑसिलेशंस कंप्लीट होती हैं उसे हम क्या बोलते हैं? फ्रीक्वेंसी बोलते हैं. व्हाट दैट कॉल्ड? फ्रीक्वेंसी. व्हाट इज फ्रीक्वेंसी? द नंबर ऑफ ऑसिलेशन कंप्लीटेड इन 1 सेकंड इज कॉल्ड फ्रीक्वेंसी. इज कॉल्ड फ्रीक्वेंसी. एक सेकंड में कितनी ऑसिलेशंस कंप्लीट होती हैं उसे हम फ्रीक्वेंसी बोलते हैं. जैसे सपोज करिए न्यू इज द फ्रीक्वेंसी. सपोज इफ न्यू इज द फ्रीक्वेंसी मींस न्यू रेवोल्यूशन या न्यू रोटेशन कंप्लीटेड इन a new cycle. See, this is the cycle. New cycles completed in 1 second. Then one revolution completed in 1 by new second. Yes, one revolution is completed by 1 by new second. Then what about the one revolution? That is the time period T. It means T is equal to 1 upon nu. Nu is equal to 1 upon T. This is the relation between the frequency and the time period. Time period is inverse. If you know the time period, you can find out the frequency. Suppose I have the time period of Earth, that is for revolution, that is 24 hours. Then what is the new for Earth? That is 1 upon 24 into 60 second. We can calculate its frequency. If you know the frequency, you can find out the time period. Nu is equal to 1 upon T. You will say, sir, why are you explaining this? Because without this, there is some problem to us. Now, what we have, this is a frequency. Suppose, now, I will say, कि frequency and there is a relation we will see. I have, this is the wave. Now, time taken to complete one cycle, this is equal to T, this is the time. And one term is this, यहाँ से लेके यहाँ एक crust और this is called the wavelength. Lambda, length of the wave, that is lambda. This is T. What about the velocity of the wave? What about the velocity? Velocity is equal to distance upon time. You know, distance कितना हुआ? Lambda. Time कितना हुआ? T. So distance is lambda T. Velocity is called lambda upon T. What is T? 1 upon T equal to v. Velocity is equal to lambda into nu. Lambda into nu. This is the relation. If this velocity is equal to c, velocity of light, then the relation becomes equal to lambda into nu. This relation is not for applicable for which one? For matter waves. This is for only the transverse wave. We can say nu is equal to c upon lambda. Nu is equal to c. C is the constant. That is 3 into 10 power 8 meter per second. And what is lambda? This is c. It means nu is inversely proportional to lambda. More is the wavelength, lesser is the frequency. Lesser is the wavelength, more is the frequency. If you see, you have the spectrum. You know, when we pass the light, see prism, then there is a visible spectrum, that is Vibgyor. This is for red and this is for violet. Okay, this is for violet. This is our electromagnetic spectrum. Below here is IR, infrared. Then we have the microwaves and then we have the radio waves and we have the microwaves. Toward this side we have which one? Your ultraviolet, then we have X-rays, then we have gamma rays, then we have that is cosmic rays. This is the electromagnetic spectrum that you have studied already. So see, but about this radio waves, it has the wavelength that is very large. I mean, it has the less frequency, and it is a more frequency is the cosmic rays. You could say gamma rays have more frequency. So in order of arranging in terms of wavelength increasing or decreasing, that is the electromagnetic spectrum that you study in the 5th unit. Now radio waves have the lesser which one frequency and more wavelength, and in this case this gamma rays have more. See, in this case violet rays have more frequency and the red wave have less frequency because its wavelength is more, its wavelength is less. Okay, as we go toward this side, wavelength will decrease, lambda will decrease, and we go toward this side, lambda will increase, and toward this side frequency will increase, toward this side frequency will decrease. Okay, the new is proportional to lambda. Now one thing I want to explain you. See this how many waves that is completed in 1 second. Suppose here is a 1 second. Then how many waves? Only 2 waves are completed. Suppose here is 1 second, and how many we see? In this case, see in which case the frequency is more. Here the frequency is more. Here the frequency is less. See, means frequency depends on the colors. It depends on this colors, and whatever your which one your this intensity that does not depend upon the color. It depends on the color. Which color you have? You know, light consists of a photons. Just like a particle's nature, the light consists of a photon. If there is a photon means just like I want to explain a photon. This electron, proton, on. तो इन पार्टिकल्स नेचर इसका फोटोन जो है लाइट के अंदर होता है और फोटोन के पास एनर्जी कितनी होती है E = actually we will explain it. Okay, it means which is a more energetic photon, the violet photon or a red photon. Red photon is less energetic because H is the electron that is constant, but frequency here that is more in case of violet. तो violet light का जो photon होगा more energetic होगा, red light का जो photon होगा कम energetic होगा. ऐसे gamma rays का photon ज़्यादा energetic होगा, radio waves का photon कम energetic होगा. तो इस टॉपिक से ये हमारा थोड़ा सा introduction था. अब हम चलते हैं that is the photoelectric effect and types of emission and work function. So we will explain it. We have less time, that's why I'm going some fast. So now we will explain which one your हम लोग explain करेंगे. देखिए what is photoelectric effect. क्या होता है? मान लीजिए हमारे पास कोई मेटल का पीस है. किसका पीस है? मेटल का पीस है. नॉन मेटल्स भी फोटोइलेक्ट्रिक इफेक्ट शो कर सकती हैं. इवन गैसेस एंड लिक्विड्स आल्सो शो फोटोइलेक्ट्रिक इफेक्ट. नाउ व्हाट विल हैपन, हमने इसके ऊपर क्या स्ट्राइक की? लाइट स्ट्राइक की, मींस फोटोन स्ट्राइक की. जब उसके ऊपर लाइट स्ट्राइक की तो क्या होगा? इसमें से कुछ इलेक्ट्रॉन्स बाहर निकल के आएंगे. इसमें से क्या निकल जाएंगे? बाहर इलेक्ट्रॉन्स बाहर आएंगे. जब हम किसी मेटल के पीस के ऊपर क्या फेंकते हैं? लाइट फेंकते हैं, लाइट इंसिडेंट कराते हैं तो उससे इलेक्ट्रॉन्स बाहर निकल आते हैं. इस फेनोमेनन को क्या कहते हैं? फोटोइलेक्ट्रिक इफेक्ट. व्हाट इज कॉल्ड? फोटोइलेक्ट्रिक इफेक्ट मींस द phenomenon of emission of electrons from preferably what means preferably हम प्रेफर करेंगे मेटल्स को रेफरली फ्रॉम metal surface when light of suitable frequency is incident on it. What is called? This is called the photoelectric effect. The phenomenon of emission of electrons preferably from a metal surface when light of suitable frequency is incident on it. What is called? This is called the photoelectric effect. So, this Holloch and Leonard have done the observation. As you know, there is a hard experiment that you have studied in your. This is a photoelectric effect. Simple. जब हम किसी metal surface के ऊपर इसको फेंकेंगे, लाइट को फेंकेंगे तो उसमें से इलेक्ट्रॉन्स क्या निकलेंगे? बाहर निकलेंगे. और इस phenomenon का नाम क्या है? That is called means light of suitable frequency. Light should be some required. That frequency should be required. कुछ frequency की light होनी चाहिए जिससे बाहर निकलेंगे और इस phenomenon को हम क्या बोलेंगे? Photoelectric effect बोलेंगे. What we can say it as photoelectric effect. Now, as you know, Hertz have done in experiment of production of EM waves. As you know, this is the induction coil, and here is here is some plate, here is another plate. You know this, and you know there is some. These are the plates. And so I want to explain you. This the plates is there, and there is spheres, metal spheres are there that are attached here. So these spheres, there is a metal spheres, And here is the detectors. Another spheres are here, and this is the detector. Now what will happen? I'll explain some shortly. This is just like a capacitor. This plate is becomes positive, this becomes negatively charged. But this sphere become positive charge, this is negative. But the air here that get ionized. If the air get ionized, then there is the production of charge. If there is a charge, if the charge will move, that is possible for the electromagnetic wave, electric field as well as magnetic field. The varying electric field will produce varying magnetic field, and varying magnetic field will produce varying electric field, and vice versa. So this is the बट वी कैन से यहाँ पर क्या होगा, EM वेव्स प्रोड्यूस होंगी. अब यहाँ पे EM वेव्स जब प्रोड्यूस होंगी तो यहाँ पे क्या होगा, आपके पास चार्ज डेवलप होगा, तो यहाँ पे स्पार्क होगा. तो बट विल हैपन दैट वेव्स कम्स टू हियर एंड आल्सो चार्ज विल ऑसिलेट हियर. वी विल फाइंड हियर इज आल्सो द स्पार्क. मींस इलेक्ट्रोमैग्नेटिक वेव्स कैन प्रोपेगेट फ्रॉम हियर टू here. These are the metal spheres now. What we will do? We will incident light on it. But what will happen? This spark will more. This spark will. But it shows. Means charge will. These electrons will release more. The electron will charge will release more. Then there is a production of EM waves. That is what we can say. It accelerates this. It accelerates. It means electrons are coming out of the metal surface. Electron किससे बाहर आ रहे हैं? Metal surface से बाहर आ रहे हैं. If the electrons will comes outside the metal cell, that proves the photoelectric effect. Now we have also Holoch and which one your Holoch's and Lenard observation. Holoch. This is the Hertz experiment that we have done already. Holoch's and Lenard experiment. What is Holoch's and Lenard experiment? What will they will take a which one your gold leaf leptoscope that I have explained there in my topic. You can see my YouTube channel, that is SK classes for physics. What is leptoscope? See, यहाँ से एक मेटल रॉड आएगी यहाँ पे नीचे को, और यहाँ पे हमने क्या लगाएंगे, गोल्ड लीफ लगाए हैं. हमने सपोज करिए इसको क्या किया है कि इसको नेगेटिवली चार्ज कर रखा है. कैसे कर रखा है? नेगेटिव चार्ज by induction, by which one, any method by conduction. Now what will happen here? This is a gold leaf leptoscope. What we will do now? It will connect it with, suppose we have a zinc plate here. We have a zinc plate. Now what will we do? We will strike which one? What the zinc plate? What will we do? We will fall light on it. We will fall light on. What will happen? The electrons will come outside it. Electrons will come out. When the electron, see, this is a negatively charged zinc plate. So what will happen? This is, when the electrons comes outside from it, what will happen? These leaves start converging. These leaves start converging. The charge start reducing. This is also an evidence. When we fall light on the metal surface, electrons will eject from the metal surface. This is not for all frequencies, but there should be a minimum frequency above which the photoelectric effect will take place, below which the photoelectric effect will not take place, or that minimum frequency is called threshold frequency. What that called? Threshold frequency means ऐसी frequency जिसके ऊपर photoelectric effect जो है, अगर उससे ज्यादा frequency करेंगे तब होगा, उससे नीचे फोटोइलेक्ट्रिक इफेक्ट नहीं होगा. उस फ्रीक्वेंसी को हम क्या बोलते हैं? थ्रेशोल्ड फ्रीक्वेंसी. टोटली न्यू नॉट थ्रेशोल्ड फ्रीक्वेंसी, द फ्रीक्वेंसी above which the photoelectric effect will take place and below which one your photoelectric effect will not take place. That is called the threshold frequency. We will discuss it laterly. Now we have this the photoelectric effect. Now we will discuss types of emission. कितनी तरह से आपका चार्ज बाहर आ सकता है, इलेक्ट्रॉन्स कितनी तरह से बाहर आ सकते हैं. देखिए, मान लीजिए आपको पता है टाइप्स ऑफ मिशन की हम बात करें, तीन तरह का मिशन होगा. वन नंबर फर्स्ट इज कॉल्ड थर्म आयनिक emission. Then there is your emission, and then there is your thermionic emission. Then there is your which one, your photoelectric emission, and then there is your secondary emission, and there is your which one, your field emission. There is a four types of emission. See, this is the first number, this is second, this is third. How we can get the electrons outside from the metal surface? See, suppose I have seen, you know the structure of an atom. You know there is a nucleus. Nucleus contains positive charge, and there is electrons in the first orbit. There is two, and so on. It will there. The electrons are there outside the metal surface. See, these electrons are loosely bound. If we see, the definition of metal is then there is a large number of free electrons in the metals. In insulator, there is no free electron. In semiconductor, there are few electrons that will be there. If their conductivity lies between metals and insulator, that I have explained in my topics. Okay, so here these electrons are loosely bound to the nucleus, see, but the net charge on this atom, that is equal to 0. That we know how, because atom is electrically neutral. Number of protons is equal to number of electrons, that we know. Number of protons is equal to number of electrons. What will happen, see, when we apply the energy to this anyway, we will apply the energy to this metal piece. What will happen, these electrons get free. If the electrons get free, then what will happen, there is another atom, suppose here, there is another atom here, this electron will comes outside from the metal surface. It will comes outside from the metal surface. Now, this electron will go, this strike with this electron also, this will comes also outside. Is the case. This is the total crystal lattice. This is the total crystal lattice. Now, this electron will not go outside itself. Will like na, see, electron will not go outside. ये इलेक्ट्रॉन बाहर नहीं जाएगा. Okay, तो type of emission की, see, electron will not go outside. Why it is not? What is the charge, total charge? If electron will release, what is the total charge? That is equal to C here. That is again equal to 0. Charge is equal to 0 because at this total material that is electrically neutral. When the electron will go out, suppose electron go outside this metal surface. Here is a positive charge that is neutral, and there is a force between them that is very large because the distance between a force is multiplication R square as well, Coulomb's law. तो R कम होगा तो फोर्स ज्यादा होगी, तो फोर्स ज्यादा होगी तो ये इलेक्ट्रॉन को वापस ले आएगा, इलेक्ट्रॉन फिर से वापस कहां आ जाएगा. It means electron can't leave its lattice, its surface. So electron will move freely inside the metal surface. That's why it is called the free electron. What is called free electron? तो thermionic emission means ऐसा फिनोमेनन जिससे हम हीट दे करके, कोई मेटल है हमारे पास, मेटल का पीस है, हम उसको हीट देंगे और इलेक्ट्रॉन को बाहर निकाल देंगे, उस फिनोमेनन को क्या कहते हैं, थर्माइनिक एमिशन. नाउ वी हैव फोटोइलेक्ट्रिक एमिशन. हम लोग अगर किसी मेटल सरफेस के ऊपर लाइट फेंकते हैं और उससे इलेक्ट्रॉन्स क्या हो जाते हैं, बाहर निकल जाते हैं, उस फिनोमेनन को क्या बोलेंगे, उससे क्या बोलेंगे, फोटोइलेक्ट्रिक एमिशन. सेकेंडरी एमिशन मींस हमारे पास मेटल का पीस है, हम उसके ऊपर हाईली एनर्जेटिक इलेक्ट्रॉन्स ही फेंकेंगे. क्या फेंकेंगे, हाईली एनर्जेटिक इलेक्ट्रॉन्स फेंकेंगे और यहां से इलेक्ट्रॉन बाहर निकल जाएंगे और इन इलेक्ट्रॉन्स को हम सेकेंडरी इलेक्ट्रॉन्स बोलेंगे. तो इस फिनोमेनन को बोलेंगे सेकेंडरी एमिशन. अब बच गया फील्ड एमिशन. हमारे पास कोई मेटल का पीस है, हम उसमें हाई मैग्नेटिक फील्ड, इलेक्ट्रिक फील्ड अप्लाई कर देते हैं, पोटेंशियल अप्लाई कर देते हैं. सपोज करिए हाई पोटेंशियल दैट इज ऑर्डर ऑफ 10 पावर 8 वोल्ट में इलेक्ट्रिक फील्ड अप्लाई कर देते हैं, तो यहां से बाहर क्या निकल जाएंगे, इलेक्ट्रॉन निकल जाएंगे. इस फिनोमेनन को कहते हैं सी थर्माइनिक एमिशन. थर्म मींस हीट के कारण, फोटो मींस लाइट के कारण, तीसरा इलेक्ट्रॉन्स के कारण, खुद इलेक्ट्रॉन स्ट्राइक करेंगे तब भी इलेक्ट्रॉन बाहर आएंगे. फील्ड एमिशन मींस सेकेंडरी एमिशन. फील्ड एमिशन मींस हम इलेक्ट्रिक फील्ड अप्लाई करके भी इलेक्ट्रॉन्स को बाहर निकालना. How many ways to get the electrons outside? See, in this case we can say these are called thermines. Electrons का नाम क्या हो जाएगा, thermines. यहाँ पे electrons का नाम होगा photoelectrons. But you can say these are the photoelectrons. यहाँ पे secondary electron और यहाँ पे simply electrons. We can say this. Electrons come outside. These are light के कारण निकलते photoelectrons. अगर निकले heat के कारण तो thermines बन गए. Electrons का नाम क्या बन गया, thermines. और ऐसे simply electrons and these are the secondary electrons. Okay. So these are the ways. Now what will happen? We will use any field, any emission here. We will apply the energy to this atom, this crystal, this metal. What will happen? This will overcome this force, and this electron will come outside from the metal surface. What this called? This is called the types of emissions. It's called the types of. Now we have the work function. What do we have? The work function. Now what will we do? We will apply the energy to this metal surface, and this electron will just leave the metal surface, and its velocity become equal to 0. Then this is called the work function of the metal. What is called the work function of the metal? Means यहां से सिर्फ इलेक्ट्रॉन बाहर निकलकर रुक जाएगा. Means just leave the metal surface. The work done to leave the electron from the metal surface is called work function of the metal. Means what is the work function of the metal? Work function of the metal is work function का जो हमारा definition रहेगा, that is the minimum energy required by an electron. The minimum energy required by an electron, the minimum energy required by an electron to just leave the metal surface is called what is that called? That is called work function of metal. Now different metal have different work function. Suppose cesium का work function 2.1 electron. You know electron volt. What is electron volt? That is, suppose we have I have applied the potential B. Suppose I have applied the potential B and I have an electron. The electron will acquire the kinetic energy. It will move toward the positive charge. Means it will acquire some kinetic energy. The kinetic energy acquired by the electron while moving through a potential of 1 volt, that is equal to 1 electron volt. That is equal to 1 electron volt. 1 electron volt means 1.68 10 power minus 19 coulomb into volt. Coulomb into volt is called joule. तो 1 electron volt किसके बराबर होगा? That is this is how much joule? How much joule it is? 1.62 10 power minus 19 joule. That is 1 electron volt. So cesium का work function is 2.9. If we talk about platinum, its work function is very high. That is 5 point something electron volt. See, means if we release the electron from the cesium, we have to apply small energy. We have to do small work. But in case of platinum, the electron will not come outside. We have to apply very high energy because its work function is more. So we have a group. If we have a group, we have a table in our book. Which metal have the more work function? See, work function nothing with the minimum energy required to just leave the electron from the metal surface. Just leave. What is its kinetic energy after releasing? That is equal to 0. लेकिन अगर हम ज्यादा एनर्जी अप्लाई करते हैं तो इलेक्ट्रॉन विल मूव. सी टू थिंग विल हैपन. वन इज द वर्क फंक्शन एंड सेकंड इज द काइनेटिक एनर्जी. Second is the kinetic energy. Whatever you will do the work, that will be converted into two things. One is it has some work function and some kinetic energy required. See the case. Suppose I have this is the case for platinum and this we begin to the work function with 5 knots. This is not correct. It's called 5 knots. So this is the work function of the metal. Work function of the metal. Different metal have different work function. The metal which have more work function, then we have to apply more energy to release the electron from that metal, and that's the free electron that will come outside from the metal surface. And we have suppose cesium, we have to apply less energy. So we have a table in if we suppose if I have the case of nickel, तो nickel के केस में भी high value होती है इसकी work function 4.9 कुछ value होती है. तो it also require very high. अगर आपसे which metal have the higher work function, it is the platinum. Means to release the electron from the platinum, we have to apply very large energy, which is we have to apply more energy. The platinum, the cesium is the case where we have to apply the less energy. I will explain you if we use the which one your suppose this is a metal. If this is a metal, if you use the ultraviolet light, then photoelectrons will emit. If in case of metal, we will use which one your visible light, then no photoelectrons will emitted. Okay, but in case of alkali metal, if there is alkali metal, alkali, you know alkali sodium extra, alkali metal, then alkali metal के केस में photoelectrons emit होंगे. तो हमें कौन सी लाइट यूज करनी? यूवी. लेकिन यूवी जो ग्लास में से पास कर, तो हम लोगों को विंडो किसकी यूज करनी पड़ेगी? क्वार्ट्ज की. इसकी यूज करनी पड़ेगी क्वार्ट्ज की. तो थैंक्स, हैव ए नाइस डे स्टूडेंट्स. वी विल डू अवर नेक्स्ट लेक्चर soon. See, this is my channel SK Classes for Physics in YouTube. You can subscribe, you can see my channel. This is my first lecture, that is in Hargar Pathshala for class +2. Thanks, have a nice day.